So for the first one, it says to find possible formulas for g of x and h of x, given that f of x is g of h of x, which is equal to that. So this is really about trying to figure out, see this as an inside and an outside function. Can you look at something like this and view it as a composite function? So my first thought, so this is one possible answer, is to think of this as a 1 over x, 1 over some stuff, and then the inside part is the x squared plus 12x plus 36. So that's one possible answer. So you could say g of x is equal to 1 over x, and h of x, the inside part, could be this x squared plus 12x plus 36. The next one, suppose that u of v of x is 1 over x squared plus 1, x squared minus 1, and v of u of x is that one. Find possible formulas for v of x and u of x. Okay, so let's see here. So when I'm looking at this, my first thought is maybe I could do the same thing I did before and let v of x be x squared minus 1 and u of x be 1 over x. But then that doesn't seem to work out. So another thing I could do on here is let the inside part be this part, this x squared. So maybe I could let v of x be x squared, and then that would make u of x be 1 over x minus 1. Okay, does that work? Okay, it certainly works with the u of v of x, because then u of v of x is 1 over, and then we put it in minus 1, x squared minus 1. But does it work with v of u of x? And v of u of x is, well, v of x is just square the thing, so it's 1 over x minus 1 squared. Oh, yeah, because 1 squared is 1, so 1 over x minus 1 squared. Okay, so I told you before that at first I was thinking of maybe letting u of x be 1 over x and v of x be x squared minus 1. So that would certainly give us the right u of v of x would be 1 over and then x squared minus 1. But if we did v of u of x with that one, we don't get the right thing, because that would be 1 over x squared minus 1, which is not equal to what it's supposed to. So, in other words, my first instinct for u of x and v of x didn't work, so I modified that slightly to get the other thing. Okay. All right, next one. Let p of x equal that and q of x equal that. Find u of x so that q of x is equal to p of u of x. Okay, so we want q of x is equal to p of u of x. Okay, so q of x, which is, so this is what we want, q of x to be equal to p of u of x. Okay, so q of x is that. So that's square root of x minus 3. And then I want that to be equal to p of u of x. So that's 2 times u of x minus 3. All right, so I can add 3 to both sides, and I get square root of x is equal to 2 u of x. Okay, so I want to solve now for u of x, so I can divide by 2, and I get u of x is equal to square root of x over 2. So I think that'll work. Let's test it out. See if that u of x works. So if I do p of square root of x over 2, that gives me 2 times square root of x over 2 minus 3, right? So if I plug in that for that x, so that gives me square root of x minus 3, which is the thing I was shooting for. Okay, so that means my answer then is u of x is that thing. Okay. Next one, it says let r of x equal that thing, and I want to find r inverse. Okay, so an inverse function is basically switching the inputs and outputs. So there are a couple ways to do this. One way that sometimes students like to do it is to just switch our x's and y's and solve for x again. So if we let x equal 3y minus 4 over 2y plus 5, then that has switched my inputs and outputs now. And so then if I solve for y, I should get what I want. So I'm going to multiply both sides by 2y plus 5. Now remember, my goal is to solve for y here. So I need to distribute this x, and then I'll try to get everything with a y on the same side together. So I have 2xy plus 5x equals 3y minus 4. Now I can see that the terms that have y in them are this term and this term, so I want to move them onto the same side. And everything that doesn't have y, I'll move to the other side. So I'll get 2xy minus 3y is equal to negative 4 minus 5x. So if you switched them around another way, you might have had all the signs swapped from what I have, which is also fine. I can pull the y out. And then I can divide by this leftover stuff here. So if I divide that over, I get y equals negative 4 minus 5x over 2x minus 3. And again, like I said, you could have done that in such a way that you have all the signs flipped, and that's still the same answer. So this is our R inverse of x. All right, next one, we have a function representing the temperature of a cup of coffee, t minutes after it is poured. Okay, and I want to find a formula for the inverse function of fh. Okay, so let's see here. So I have h equals 75 plus 110 times 0.9 to the t. Okay, and so what is the meaning of f inverse of h? Well, what this is going to give me is that if I know the temperature, I can get the time, right? But that's opposite of this one, because this one, the input is time. Or sorry, the input right here is time, and the output is temperature. So this is doing the opposite of that. Okay, so basically what we want to do is we want to take this thing and we want to solve this for t. And that will give us what we want. Okay, so to solve that for t, I'm going to subtract the 75. Okay, then divide by 110. Okay, and then I can take the natural log of both sides. And I went ahead and moved that power down and multiplied by the natural log, and then I can divide. So I get t is equal to natural log of h minus 75 over 110. All of that's inside that natural log, divided by natural log of 0.9. Okay. And then now, if I know this input here is a temperature, okay, and if I input that temperature 150, then I will get out the amount of time that that coffee has been cooling. And so I'm going to plug that in for t. So f inverse of 150 is going to be natural log of 150 minus 75 over 110 over natural log of 0.9. So I'm going to plug all that into my calculator and see what I get. So one thing I have to be a little bit careful of when I plug this in is to make sure that you put additional parentheses around that top part. So I got, for my final answer, 3.63. Does it say round to one decimal? So 3.6. And what are the units of that? Well, let's see. That's a time, and the time was measured in minutes. so 3.6 minutes. Okay, and so what that's telling me is that if the temperature of the coffee is 150 degrees Fahrenheit, that means the coffee, this particular cup of coffee, has been cooling for 3.6 minutes. The next one, I have f of x is sine x and g of x is x squared. I want to combine these functions in this way. So this is just function addition. So f of x plus g of x is going to be sine x plus x squared. Okay, so that's my answer for A. And for B, this is just multiplication. So we're just multiplying the two functions together. So we'll have, so it's g of x, f of x, so we'll just do x squared sine x. We could have written sine x times x squared. It would have been the same thing because multiplication is commutative, so we can multiply things in either order. This one says g of f of x, so that means I want to, the function g is x squared. So I'm going to square whatever it is. The input, we're inputting this sine x in there, so sine x, the whole thing squared. If you want to, you can write that as sine squared of x. It's kind of a shorthand way of writing that down. But really what we're doing there is we're squaring the whole thing. So you really need these parentheses around the sine of x. It's not just sine of the x is squared. So does that make sense? All right.